Good day, guys. How are you doing today? This study is dynamic memory allocation in C++, from raw pointers to modern smart pointer. In our former place, in our C play series, we'll discuss more on memory management as well. But let's look at what memory management does in C++ and how is it different from C type of memory management. Why do we need Why do we need dynamic memory management? We are going to look at all those questions as well. Now let's look at it. We have the stack. The way we manage memory are in two ways in C++. Also the same way also in C. It's the stack and the heap. The stack is when we manage their code, when we allocate memory to a variable at compile time. But at the dynamic time, at the runtime, we make use of the heap memory. We allocate memory in case the stack memory allocation gonna run out of scope. Then let's look at the what. Let's just suppose it now. Let's see the stack memory is managed automatically, but the dynamic memory is managed by the developer or by the programmer. The size is known at the compile time, that for stack, but at the runtime size is known. Compile time is very fast, slower than the heap, though we have enough space at the heap. The lifetime is tied to scope, e.g. functional call, but the lifetime is tied to what? To the new and delete method. We create it with the new method or with the new keyword, and with delete keyword is the memory allocation is freed. Then let's see a sample of it. The sample of it is what we have in 30. In 30, it means we are allocating 30 to a 4 byte here. Here we have what? Pointer. This is a pointer on the heap. We have much memory, so we are allocating 30 to it as well. In case also we want to deal with objects, we create a class called, assuming there's a class called student, we create an object of student1 from it. On the heap as well, we can also do that. Yeah, you see the new, but remember that we can also create a what? We can create without asterisk and new, but for it also work on the stack as well. But if you want it to work on the heap, then for more memory allocations, you can use the pointer and dynamic memory allocation. Then let's look at why do we need dynamic memory allocation. Use the memory allocation. Use the key takeaway that we need to talk about is that use the heap when object lifetime must extend beyond the current scope, or when the size or number of objects is unknown at for time. What does it mean? That in case if you know, okay, the total size of this variable you declared cannot go beyond this, then you can use compile time. But if you know that it's likely to go beyond that as your program goes and as your data increases, then you can use the heap memory. Also, the dynamic memory allocation for objects. You can see for student and student1, we created it for object the other time with the new keyword. Also, you can also read it, but let's see here. You also create object on the heap at runtime, essentially when the number of size of object is unknown beforehand. For instance, we see the student and the student1 here in the above. The student and so here one can see that we created a student on the heap memory using the new keyword. You can see the new keyword. The new enable help us to allocate memory on the heap for an object of an array or an array of objects. Of course, you can also allocate what arrays of objects for it on the heap as well. Cause the appropriate constructor to initialize the object. Return a pointer to the allocated memory, which is the student1. This is the p student here that we're talking about. Then we also have delete. Cause the corresponding destructor to clean up the objects. So this is very, very essential. Anytime we create a constructor, we need to delete it. Deallocate the it and free it. We should avoid some errors like double freeing or looking for pointer that be freed that can cause a pointer dangling pointer. Then let's look at some syntax and usage. Single object. You create a single object, like for example, a class name. You have a pointer here for a single object here. You have a new here. You can take in some arg, or if you don't take any, you can take, if you take in some args, argument here, maybe you are assigning something to it, or you don't assign anything to it. Maybe you don't assign anything to the constructor. So that means it uses the default constructor. Also, the other way around, we have array of objects. Taking the array of objects and take the size of objects. How many do you want to create? There are 2 or 3 arrays, elements of objects in the array list. The allocation is done this, delete just with the ordinary single pointer object, then delete the array of objects here with the same thing. Distinction, let's see some crucial distinction here. Always smash delete with a single new and delete with a new that allocate an array. Smashing delete will undefine behavior in our program. Then let's see example, the building class. Let's see a building. Let's create a building, constructor and destructor calls. Let's create a class. We have used to creating classes. In our video series, you have seen how we create classes. And we also got, you get string, we get address, assign variable to it, not applicable. Now, and f equal to 1, then we use initializer list to initialize this address to the address of this, then flows to the what to f, then we constructor building a building created at this address, and behind the line, destructor to destroy and free all resources as the class goes out of the scope. So destructions, tearing down building address and this automatically called. So display information about this, you have it here. Then let's come to our main code here to see how we can apply memory allocation with it. One time for more visibility, let's see int main, you can see that allocating single object as a building object, you can create what taking address and take what the floor. Can use, although don't forget this and not the dot operator when dealing with pointer and memory allocations in C++. Then also we look at this, allocating this, then number of apartment 3, this. We store them in an array. We have one object, we have another object. So then we now look through it. Number of apartment, in number of apartment equals, we want to get the new, because the number of apartment equals 3. We have another apartment, we have apartment, we have office there. So the number of apartment equal to 3. We have 3, number of apartments equal to 3. We put it there at the number of the array size. We are expecting 3 apartments. The first one is this. The second one is this. And the third one is this. This is stored in this array. Now, previous lecture, you should understand this better. Then we are able to know that, oh, this is the number of apartments here, apartments here, sorry. We also have apartment of the first index that display information about it. So through the help of our constructor, God gave us the information, the address of these informations are passed through the constructors. Correct. Then we display the information. Can you see? We delete the office for single array of objects here. With this for single, and we delete it here. And for the arrays, we delete it here without mistakenly enter a misappropriating of what? Of deletion for the memory or for the object. Expect the output. You can see the output here. But let's see what causes memory leak. A memory leak occurs when you allocate a memory on the heap, but fail to deallocate it before the pointer go out of scope. So a memory leak, for example, now, as we just do this, as we just finish this program execution, you fail to apply delete to this office object, and you delete this other one. That will be a memory leak for the office. So memory leak here. So, and we allocate on the memory. So we fail to free it. So, and you can see, let's see a sample of it. Maybe that you program, you forget to free it, You can, let's see a sample of it here. You create what? The building, P building, this. The function ends, the building is destroyed. Once the functions end, the building is destroyed, but you don't, that's what there's a leak. There's no way you free it. You don't even free it here. And this does not, you have to delete it after finishing it, because this function does not even return a pointer. So you have to, it's not returning a pointer of this. Assuming you return a pointer, that's okay. Maybe you are returning through this may create a leak. But this will create a leak. So it's good that there's going to be a leak. Memory leak happens here because this function is already gone out of scope from this. This is the beginning of the scope and this is the end of the scope. So now, small leak can add up, causing a program to eventually run out of memory and crash. Some of our program run crashes, you can see in the world around you. So if this can lead to what? Billions of dollars lost in, or billions of naira lost in, depend on the kind of application. If it's deployed on the e-commerce platform that a lot of users are using it. So it can lead to loss of money. So dangling pointer, a pointer that continues to point to a memory location has already been deallocated. You already free it, delete it, here you are still referring to it again. For instance, this is an instance of the building object. Then you are after deleting it here, you are not still calling it from here again to call it again. It's cache undefined behavior here. Then the best practice is to set pointer to null point PTR after deleting them to prevent accidental use. After you've already deleted this page now, you can easily what? We explain this better also in our C program. You also need to what? Put them. We also explain them, so we are not doing better. We also explain it as well. You need to point it here so that there won't be a need that you're already referring to it again. So if you refer to it anytime, you get a null pointer. Double free, deleting, you get double free. After you are free you are free first time, you are free second time again. So this can crash and delete what? You are free second time after you free. Just assign a null pointer to it. Handling allocation failures. What if the system runs out of memory? The new operator will throw an exception of type bad allocation. Or for robust application, you should wrap critical allocation in try and catch. We'll talk about try and catch in some of our upcoming videos. Then we explain it, how we can also put here, the program will execute here. If this program fails to execute, there will be a custom message that is allocation fail instead of the program being failed. So it is well encouraged for programmers to write their program with, if in case maybe you are opening a file, you are closing a file, and this thing is likely that it may throw an error. So you put it inside a try and catch error. The same way also Java did this one also as well, even C# as well. But what differentiates them is what? Is the kind of exception used. So the kind of exception used. So maybe I overall found exception, find of those exception, out of band exception, you see them. So the problem with throw pointers now. Manual memory management with new and delete is powerful, but error prone. Forgetting to delete causes memory leak. Using a pointer after delete is dangling pointer. It causes a dangling pointer. Calling the delete twice is called double free. If an exception occurs between new and delete, the delete is skipped, causing a leak. Get that message. If an exception occurs between the new and delete, the delete is skipped. If an exception occurs before you get the delete, and it can cause a memory leak. The better way is to use what are called the smart pointer. The smart pointer is a class that traps a raw pointer and manage the memory automatically. The most common type is what? The unique PTR. Raw principal resource acquisition is initialization. That's formula of RAAI. The object lifetime is tied to the unique pointer. When the pointer goes out of scope, the memory is automatically deleted. It's automatically deleted. So once it goes out of the function, brace open braces, exclusive ownership, only one unique pointer can point to an object at a time. You cannot copy it, only move it. No delete is needed in this. No delete is needed in this. We create a function this, we create we want to create a unique pointer. No new is used indirectly. So we use smart unique building. Then you assign our value to it. Smart over address here. We are using a smart pointer here, so we don't need of the new and we don't need of the delete. So the smart pointer does display informations. Once there is out of scope here, from this and this, the closest point here, the memory automatically freed. Here is where smart pointer goes out of scope. So then no leak occurs, no problem occurs. So I advise for you to use a smart pointer instead of a raw pointer. But we put it there so that you understand how it's being done as an engineer or scientist. Let's see the difference. Let's see the difference between the stack and the heap. Then the stack versus the heap. Let's understand when and why we use them. Manual management. New allocate a construct. Delete, deallocate, or destroy. So always match new with delete. Anytime you use the new, you use the delete. Heap. Stack versus heap. Understanding when and why to use direct memory. We use, okay. Pitfalls. Let's see the pitfall. Be vigilant against memory leak, diagonal pointer, double freeze. Those three errors are common in the memory allocation. Though we don't even talk about double freeze, I think we don't even talk about that in C program that we put on the playlist, but we have to double freeze. We see a sample of it in our C programs. Let's see some key takeaway here. Understand, and let's see. Modern C++, manual memory management is hard. Use smart pointer to automatically manage our work to avoid all this error. In case, thank you very much. In case you have any questions on this, please drop them in the comment below. Please like, share, subscribe. Bye-bye.